Happy Monday. Go ahead and correct your answers. Pause if you need to. I heard that some of you are having trouble with 18 through 20, so I want to do one of those. I thought 19 looked the hardest, so even though it was an odd, that's the one I decided to do. So I think the thing that made these the hardest was, not that they were actually hard, but maybe that those crazy diagrams confused you. I don't know. We're supposed to solve for h in this one. So I don't know if you tried distributing the pi r. It's actually, in my opinion, easier to divide by the pi r right away. So then we'll have s over pi r equals h plus k. So then to solve for h, you'll just subtract the k over. So I didn't think that these three were any harder than the other ones, you know. And then after you solve for h, then you were supposed to plug in, it said a 2 for the r and a 50 for the s. Pi is already a number, and a 3 for the k. So apparently that comes out to about 5 centimeters when you type that all in. Yeah. So if you have any more questions, I can help you some more tomorrow. Today's lesson is about using problem-solving strategies and models. And so today's lesson is just to teach us not to be afraid of word problems. Here's a little table of numbers that has the floor number versus the height of the ceiling. So the lobby's 20 feet tall. Once you get up to the first floor, you're 32 feet up to that ceiling, 44 feet. So we're just kind of looking for a pattern here. Do you see the pattern? For every increase in floor, we have an increase of, is it 12 feet per floor? So one thing to think about is if we've got 12 feet per floor, that's our rate, right? That's like a rate, like miles per hour, feet per floor. And so when you're thinking like your mx plus b, that's your rate, that's your slope, that's your rise over run. And so let's try to write an equation. Do you want to write it with y and x, or h and f? It doesn't really matter. So in this one we start at 20 feet and then we add on an extra 12 feet per floor. And if you want to check to make sure that works, you could try plugging in a 2 and see if it comes out to 44 feet. And then predict the height of the 20th floor. We made our x value be our floors. So we're going to plug in a 20 here. $260 feet. Great. So a bunch of the problems you do are going to be similar to that, where you just need to find the pattern. Here we have age versus height, and it looks like we have an increase in height each year of 2 inches per year. So that's our rate. So if you're going to do an mx plus b, we would do the 2x, mx, plus, and then b. What would we use for b? Well, that's a great question, isn't it? I know that when I plug in, for example, when I plug in a 5 right here, I need to get a 46 right here. Can we use that? So it has to equal 46 when I plug in a 5, right? So that's 10. Should I call that my y-intercept, my b value? So I'll subtract 10. So b would be 36. So apparently if I put a 36 right here, it should work. So let's just double check. When I plug in a 7, am I going to get 50? 2 times 7 is 14, plus 36 is 50. So I'm happy with that model. Predict how tall Julie would be at age 11. So the age is our x value. Y equals 2 times 11 plus 36. I got 58 inches at age 11. At age 19, again 74 inches. at age 35. 106 when I type that in. And is this model reasonable for predicting Julie's height at any age? What do you guys think? I don't know if you've seen me lately, but I am not growing 2 inches per year. If I was, I would be a lot taller. 106 inches is like 8 foot something, and see, you're just not going to keep growing 2 inches per year. So this model is not going to be reasonable at those older ages for sure. Also, did you think about plugging in 0 for x? When this baby was born, it was 36 inches tall. That is a large baby. So it'd probably just be for a short amount of time that that model would hold, between ages 5 and 8, I guess. Sharing the drive. Andrew and Jack are taking turns driving on a 400-mile road trip. Andrew drives for 3.2 hours at an average speed of 60 miles per hour. What must Jack's average speed be for the remainder of the trip if he wants to reach the destination in 4 more hours? Make a diagram and use a formula. These overwhelm me too, so don't freak out. But for me, drawing a picture makes a big difference. So I'm just going to kind of draw this road trip from start to finish. And the deal is that Andrew's going to drive for the first part, and it might not be exactly half. I'll just split it kind of randomly. So we're going to have Andrew drive first, and then Jack. I don't know that Andrew's driving more. He's driving for 3.2 hours, and his average speed is 60 miles per hour. I'm just writing down the information so I can wrap my head around it. We are looking for Jack's average speed. That's what we'd like to know. And for the remainder of the trip, if he wants to reach the destination in 4 more hours, so we want Jack to drive for 4 hours. All right. Make a diagram. Use a formula. Oh, there's one other number I don't have here. That is that the entire trip is 400 miles long. And then maybe I would just ask you, do you guys know any formulas that relate time with speed and distance? That's what we have going on here. Did you say distance equals rate times time? Distance equals speed times time? I think that is probably the formula that's going to be useful. So we've got Andrew doing his distance, which we don't know his distance, right? And that's part of what makes this difficult. I think I'm going to set it up sort of like those work rate problems. I'm going to do a rate times time for Andrew, plus a rate times time for Jack, and together that will equal the total distance. Do you like that? So Andrew's rate times time, and Jack's rate times time should equal the distance. That should work, right? 192. Oh, apparently Andrew drove 192 of the miles, so turns out it's Jack that's driving a majority of the way. Doesn't matter. It helped me imagine what was going on. Divide by 4, 52. And that's a rate, so that must be Jack's miles per hour, right? Make sure you put a label on that. So I just don't want you to be afraid of these word problems. Don't just freeze up. Try writing down the information, see what you can do. This is a fun one. You're hanging flyers around a cylindrical kiosk. So you're hanging up these flyers, leaving some space between each one, all the way around. And we've got a diameter of 5 feet. 5 feet. And I want to hang 15 flyers that are 8.5 inches wide each, right? 8.5 inches per flyer. That's a rate. So they're evenly spaced. How far apart should the flyers be placed? Okay. I think the first thing I want to figure out is how much space I have to work with. I'm thinking circumference. So there's a formula that I could use for that. Circumference equals pi times the diameter. We could just leave it as 5 pi, or if you feel better calculating, did I calculate this? I think I got approximately 188. Use the pi button for accuracy. I have 188.5 inches to work with. So basically you have paper, space, paper, space, paper, space, paper, space, and all of that has to add up. So I'm going to write that paper plus space, and I want it to come as close to 188.5 as I can. All right, paper. I actually know how much paper. I have 15 flyers at 8.5 inches each, plus space. How many spaces do I need? It's kind of different because this is a cylinder, so if you think to the right of each flyer, you need a space, right? So we could actually think that there would be also 15 spaces. If there's 15 flyers, there would be 15 spaces. Now that's only true because this goes all the way around the circle, but so 15 per. So this would be, what is X standing for here? The space between each flyer? Yeah, that makes sense because then I'm taking that space, which is a rate, space per flyer, times the number of spaces I need. That works in my head. Does it work in yours? All right. So this comes out to paper. You guys probably would have calculated this at some point. And even if you didn't set up an equation like this, I'm betting you could have figured it out somehow, but the goal is that we learn to set these up as equations, since we're in algebra and all. Subtract 127, divide by 15, 4.06 repeating. I'm going to call that about 4.1 inches. 4.1 inches between each flyer. So I give just a generous 4 inches each time I tacked one up. Alright, you guys are going to do your absolute best on each problem assigned, and if you can't figure them out, that's okay, but the goal is that you try, you do your best, you get some experience. I'd rather have you make a mistake than not try at all. And I will see you tomorrow.